My name's Andy Frazak, owner of Frazak Solutions, LLC, consulting industry. Today, we're going to be talking about the Internet of Things project for the Suncoast Innovation Challenge. Part 1 of this deliverable will demonstrate my understanding of IoT, and it will also explain how that aligns with the problem of interest. I will provide a clear and concise understanding of how the two are interrelated. This project will illuminate findings by best way of practices, strategies, and tactics by and through the role of technology, cost structure, other cases, and how and why this area requires growth. IoT, also known as Internet of Things, is becoming a widely popular approach to problem resolution in various aspects of the marketplace. IoT allows us to enhance the way we collaborate within groups to resolve issues. We no longer lead a lifestyle where strategizing sessions take place on a chalkboard. Interactive tools like smartboards, online collaboration, geared softwares, and portals were formulated so we can communicate on a global scale if we wanted to with one another to resolve issues and exchange business methodologies. As it relates, the technological advancements did not stop there. IoT is also a blend of unique components, data analytics, sensors, user goods that enhance how we live life. It enables robotics and machinery to complete tasks without human intervention. IoT and the presence of microplastics are interrelated. The topic provides an opportunity for product optimization while collectively reducing a harmful irritant within our waters. While this problem is deeply concerning, unfortunately, there are no known competitors identified in the Tampa Bay region. No one has yet created a way to resolve this issue, which is exceptionally opportunistic. The issue of microplastics have been a long-time problem, both globally and nationally. As it relates, this piece of data has only surfaced itself in 2019 by Kinsley McEurchin, an environmental scientist and policy graduate from the University of South Florida here in St. Pete. McEurchin's water sample from the Tampa Bay has identified, since particles are similar in size to plankton, filter feeders such as oysters, clams, many fish, and some birds ingest microplastics, allowing them to enter the food chain. Persistent organic pollutants, including toxic pesticides and metals, can stick to their surfaces, making ingestion potentially that much more damaging. Effects including cellular damage and reproductive disruption and death. The study revealed that the predominant type of these tiny particles in Tampa Bay in both the water and sediment are thread-like fibers from fishing lines, nets, and washing clothes. Synthetic fibers are released from clothes while they're being laundered, discharged to wastewater treatment plants, and then eventually released into the bay. In the next segment, there is a graphical model that is reflective of any and all contributors to the growing problem of microplastics, illustrative of the idea behind the slew of untapped possibilities and potential for resolution. According to McEurchin, one of the main culprits for microplastics in Tampa Bay is remnants from fishing lines and nets and wastewater discharge. In other words, microplastics for us is coupled with two major concepts: overfishing and wastewater treatment plants mishandling. The focus of this next section will be on comparing and contrasting the suffrage of other regions that also have waters plagued by microplastics. Chicago, Illinois was an area of interest provided their most urbanized river had levels comparable, if not higher, than some of the oceans for microplastic detection. The North Shore Channel in Chicago, Illinois is specifically what is being evaluated. Treated wastewater effluent from the Terrence J. O'Brien Water Reclamation Plant flows into the North Shore Channel, approximately 5.6 kilometers upstream of its confluence with the Chicago River. The O'Brien plant is an activated sludge plant that treats domestic wastewater. It has an average flow of 927 million liters per day, and effluent is not disinfected prior to release. The NSC is part of the hydrologically complex Chicago area waterway system, which is highly urbanized and contains several large wastewater treatment plants. Chicago area wastewater systems drains into the Illinois River, then the Mississippi River, it may thereby introduce microplastics to downstream river and marine environments. Chicago, Illinois, and the North Shore Channel are advantageous to compare to the Tampa Bay region for the following reasons. One, they too are finding that the culprit of the issues is wastewater treatment plants and the mishandling of the water that continues to get redeposited repeatedly back into the already infected waters. Number two, similarly, 9.3% of their water effluent from upstream from the wastewater treatment plant contains fibers, just like us here in Tampa Bay. Number three, this particular sample captures multiple affected waterways. It's connected to the Mississippi River, whose water and marine ecosystems will suffer by the decision makers of Chicago, Illinois wastewater treatment plant facilities. Number four, Chicago, Illinois rivers, and it looks like Mississippi River too, both have presence of microplastic, but levels particularly close to concentrations that we see here in Tampa Bay. Around 4 billion particles worth, and Chicago, Illinois specifically at about 5 billion particles worth. So they actually have higher levels than we do, and we're talking about oceans compared to lakes. There is a huge value proposition involved in Chicago, Illinois to resolving this issue, provided that other Great Lakes are being impacted by their policymaker decisions. If they were to resolve these issues, then this can build a multifold impact. For example, if Chicago, Illinois understands the threat of microplastics and develops a plan, execution on this also would benefit the state of Mississippi and several others where the Mississippi River flows through, where the microplastic remnants are flowing into from Chicago's tainted waters. How is Chicago, Illinois solving this issue? So far, Chicago, Illinois continues to track the issue, just like McEachern here in Tampa. They're also using nets to manually collect water samples and evaluate them. They're also using what is referred to as mobile power soil DNA extraction kits to collect microplastics and organic matter samples. This system enables them to measure the issue, quantify it qualitatively, and analyze the results. Appropriately monitoring and controlling the issue is critical. This activity only has meaning when you develop a baseline for acceptability thresholds and how you want to measure those variances along the way. The way their environmental scientists have developed what seems to be efficient and functional seems to be working. Now I'd like to challenge the assertion, is this way the best practice? Is Chicago, Illinois handling this issue with the most convenient and efficient way? I think the next segment will expound upon methods utilized in other regions and how that is measured against Chicago and Tampa-based collection measurement systems. In 2021, California legislature passed a Senate Bill 1422 that mandated State Water Board develop a testing for microplastics due to scientific evidence that has come to surface. Research shows that they use a system called Raman spectroscopy. Let's elaborate a little further. What is Raman spectroscopy? This is gaining ground in the analysis of microplastics, especially due to its high spatial resolution that allows the investigation of small plastic particles whose numeric abundance is argued to be particularly relevant in the aquatic systems. Here, we aimed at outlining the status of Raman analysis of microplastics from the aquatic systems, highlighting the advantages and the drawbacks of this technique, and critically presenting tools and ways to effectively employ this instrument and to improve the spectra obtained and their interpretation. In particular, we summarized procedural information for the use of Raman spectroscopy, and we discussed issues linked to fluorescence interference and the analysis of weathered polymers, which may complicate the interpretation of the Raman signatures. In this context, a deep understanding of the different plastic polymers and their Raman peaks and chemical fingerprints is fundamental to avoid misidentification. So this is basically a piece of technology that robotically goes in the water to identify microplastics. So far, the system is flawed in that it is impacted by fluorescence, and the analysis then comes back inaccurate. Overall, I'd like to challenge, is that the best practice? Well, before being able to resolve any problem with Internet of Things, knowing how we can measure it and if that practice is suitable must first be a priority. For evidentiary purposes, creating an instrument that allows Raman spectroscopy to evaluate the scope of the problem is seemingly ineffective. It is also not cost-effective to technologically manufacture and produce a device that cannot properly detect the presence of microplastics due to the infrared interference. This brings me back to the original collection processes being used in the Tampa Bay and Illinois areas. While these processes may seem a bit dated, it is more accurate currently. What is captured in the nets and brought back to the lab for further DNA extraction and evaluation is more authentic than an expensive device that brings back insufficient data. The final piece of this brief I'll address is identifying technology or infrastructure needs, early costs, and resources that may be needed. A feed design schedule is most appropriate in this circumstance. Subject matter experts like an engineer, scientist, or environmentalist will need to be the main human resource. Helping to identify costs associated with these types of individuals to make recommendations will need to be the starting place. Acquiring costs associated with anything beyond that, such as resources or technology, would simply be inefficient at this level without having access to further data, which would be provided by said experts.
This leads me to ask, what should we do about this? How can we create a solution to the problem of microplastics plaguing our water? How can we find a way to get the water sludge facility plants, treatment plants, to be able to somehow sanitize the sludge before depositing it into the water? How can we find a way to detect the microplastics in the water? How many microplastics are in our water? How much? What's the size of this problem? As you can see that the Mississippi River that branches out to several other states and regions, they're having a problem with microplastics too, which means not only us in Tampa Bay are experiencing this problem. People who are connected at all or within proximity of the Mississippi River are also suffering from this issue. So what economic policy, specifically here in Florida, could be put in place? They could maybe, just maybe, touch other regions and help them too. But more specifically here in the Suncoast region, how can we possibly turn this story of our waters being plagued with microplastics and eliminating our ability to use them for recreation and fishing to the best of our ability? How can we make our water safe again?